of segments and angles is reflexive, symmetric, it's the notes, and transitive. Okay, so what this means is if A is congruent to A, that's reflexive. If A is congruent to B, then B is congruent to A, that's the symmetric. And transitive, it's the same exact property as reflexive, symmetric, and transitive when we dealt with equal sign, only we replace the equal sign with the symbol for congruence, which the symbol for congruent is an equal with a squiggle on top. Basically, the squiggle is the symbol for similar, and the equal is the symbol for equal, and so we combine them and make congruent. Congruent is the same shape and same size. Okay, so similar is same shape, different size. Congruent is same shape, same size. And in these properties, reflexive, symmetric, and transitive, all you're doing is replacing the equal sign with the congruent symbol. It's the same. If two segments are congruent to the same segment, then they are congruent to each other. Right? So if, let's say, A is congruent to B, and then we have B is congruent to C, so both A and C are congruent to B, that means that A and C are congruent. Okay. Likewise, if two angles are congruent to the same angle, they are congruent to each other. Also, you know, the symbol for congruent, you don't really have to write the word anymore. You can take wherever you put the word congruent and you can put the symbol in, it's the same thing. So we make a two-column proof. Okay, we use deductive reasoning. Remember we talked about inductive versus deductive. Inductive is based off of an observation, but deductive is based off of fact. And so we have to use deductive reasoning because we can only make statements that are based off of fact. We can't like make any assumptions, or we can't even look at a picture and say, oh, well, it looks the same size, so they're congruent or something like that. We have to use facts. And then the statements that lead to the required conclusions are recorded on the left, and the reasons are recorded on the right, which I'll show you that in a second. All right, to make a two-column proof, you have to have a t-chart. That's the structure of the proof. You have a t-table or t-chart. It's sometimes called a t-proof. You have to have a given statement or more than one. You have to have some sort of information, though, that is given to you to start out. Okay? Pictures make the proof a million times easier. So if you're not provided with one, you should draw one based on the given information. You have statements. These are the facts that take you from the given to the thing that you're trying to prove, and then you have to have reasons. Okay, these are the supporting rationale for the facts used. Reasons are theorems, postulates, and definitions. Oh, and I forgot, and also properties. Okay, so when I'm making a proof, I can use a definition of vertical angles, or I can use the property of addition, or I can use a postulate that lines are infinite, you know, things like that. But these are facts. And so we take the statement and then we say it's a theorem or postulate or a definition or property. Okay, so this is basically what a two-column proof looks like, or t-chart. The reason it's called t-chart is you guys see that's like the T right there. Okay, on the left we have statements, and on the right we have reasons. All right, so what we have is we have our given statement. We had to have this. And then we need to know what we're trying to prove. We have a picture. And I like to label the pictures. So I'm given that RS is congruent to SP. Well, that's my first statement, and it was given. My first statement or statements are always the given statements. Now, whenever I have these, I will mark it on the picture. RS is congruent to SP. To symbolize congruence of segments or sections, you give them the same number of lines. So I can either do one line here, and then like I could do this as 2 lines, which shows that this line is different length than those. I don't need to actually label that on this picture though, because I haven't gotten any information about that. But whenever I have parts that are the same length, I give them the same number of marks. So those are marked. And then I have P is the midpoint of SQ. That's also given. Okay. What midpoint tells me is that this point here is in the middle, which means that this distance and this distance are the same. So SP and PQ are the same length because that is the definition of midpoint. Now, I wrote it out long way, but if you wanted in your proof, you could write def midpoint. Definition midpoint. Cool. Okay, so I was given this information. I was given this information. This line here told me this. The statements will lead one to the other. So it's a definition of midpoint, tells me that SP and PQ are the same length. Well, if RS is the same as SP and SP is the same as PQ, that means RS and PQ are also the same length. That's transitive. But if you wrote substitution, it's not on this list. So you wouldn't write it here because I'm giving you the words. But if you wrote substitution and because you didn't have a list of words, that would be acceptable because you could technically substitute one for the other. Okay, so let's try a couple of these together. Okay, I have BD bisects ABC. Given. Okay, so now BD bisects ABC. What does bisect mean? Not quite. It's a specific kind of between. If I bisect something, I've cut it in two, but I've cut it in half, right? So bisect is to cut in half. All right? So if I cut this big angle in half, that means this angle and this angle are going to be the same size, right? Which is my next section. My proof statement is to prove that A, BD, and DBC are the same. I don't like naming your angles. I will accept this as long as you label it in the picture. You can do that, 1 and 2. And then instead of saying angle ABD, you could say angle 1, angle 2. So angle 1, angle 2. You could replace those if you want to. Sometimes that's a little easier. But I've got that angle 1 is congruent to angle 2 because it is the definition of bisect. Because bisect is to cut in half, and if I cut something in half, they're equal. 2 equal parts. The structure of your proof, almost always the given statements come first and then the proof statement comes at the end. The only time that those are different is, you remember when we did the if x equals 5, so prove 2x plus 5 equals 15, and then we plugged in the 5 on the next line. That's the only time you would really put the proof statement up top. Usually the proof statement will come at the bottom. Okay, so E is the midpoint of DF. That was given. Okay, so E is the midpoint, so I'm going to put that with an M, which tells me that DE and EF are the same length. And then F is the midpoint of EG. That's given. Well, F is a midpoint, which tells me that EF and FG are the same length. So I've got DE is congruent to EF. That's the definition of midpoint. Right? Because if I have a midpoint, that tells me that two sides are equal. And then EF is congruent to FG. That's also a defined midpoint. So if I have DE is the same as EF and EF is the same as FG, then that tells me that DE is the same as FG. That's transitive. Again, though, if you had written substitution, I would take it because they're so similar. But what I did is I took this one, I said it was the same as this one, and then I used this one to get to that one. Does that make sense?
Yeah.
So like 4 quarters is the same as $1, and $1 is the same as 10 dimes. So 4 quarters is the same as 10 dimes.
It's just a link.
Yeah, it's a link.